All right. Okay. Anybody remember anything about domain and range? Brad?
Range is what you get when you plug in a number for x.
Okay.
And then domain is the number you plug in for x.
Good. Very good. That's excellent. Domain is your input. We're going to talk about. I want you to think of it in terms of a machine. I'm going to use the example of like a little vending machine with candy bars in it. I'm going to say the button that you press. So your input is the button you press, and your output, the range, that's what you get out. So you hit the Snickers button and a Snickers candy bar comes out. That's the range. That's the output. Okay. Brad gave the example of when you have, say we have a linear function, and we'll talk about what I mean by a linear function in a little bit. If we make a little table, in other words, these are our inputs, these are our outputs. So if I do an input of, we can do any number we want. If I do an input of 3, what's the output for that machine going to be? 8. Good. If I input -2, yeah. So input is what we're plugging in for x. Now, if we were to look at this, let me, I'll just draw the graph here. When you plot things on the coordinate plane, you can think of it the same way. This horizontal axis, our x-axis, is for our inputs or our domain. And then the y-axis, that's for our output or our range. Let me, in other words, we're going to review this too. That 5 represents, this is a line, this is a straight line, so that's what we call linear, a line, a linear function. What is the 5? That's the, good guess. That's going to be the y-intercept, right? So, and then the slope is right in front of the x, right? The slope is going to be, you could say 1, or if you want to say 1/1. So this is our slope, and this is our y-intercept. Okay, so how do I do a slope of 1? How do I graph that? Up 1/1. Good. Up 1/1, up 1/1. So there's our line. Oops. I just wanted to plot this real quick because you could see so if you have let's see, there's 1, 2, 3. Okay, it's not perfect, but you get the idea. So when I do an input of 3, where does my output, where do we visually see that? So when I do an input like I did in my table here, when I do an input of 3, so here's my input, where do I see the output? Yes, if you follow the 3 up here, here's my output at 8. So an input of 3 gives me an output of 8. So the 3 is part of my domain and the 8 is part of my range. If I were to input 0, what would I go over the output if I put in 0? 5. So I can see my output right up here. Okay. I kind of like to think of it too, if you're thinking of like a musical instrument. When you, say, whatever instrument you're playing, when you press that key on the piano, or when you press that button on your saxophone or whatever, the output, it gives you a certain sound. That's the same thing here. When I press this button 3 here, it gives me this sound or this output of 8. That's another way to think of it. Okay. A relation, we're going to use that word for, that's just kind of listing your inputs and outputs. Okay. In other words, this is one way over here. This is one way that you can show a relation, like how things are related, basically. 3 is connected to the 8, -2 to the 3, 0 to the 5, things like that. Okay. Now, not all relations, but some relations are what we call functions. What has to be true in order for something to be a function? Very good. Okay. Each input can only have one output. Okay. We're going to talk a lot about that. That's a really important concept. In other words, if you were to think of it in terms of that vending machine, if you hit that Snickers button, and the first time you hit it, you get a Snickers. You're hungry again later, you go back down and you put your money in, you hit the Snickers button again, and this time you get a Milky Way bar. Is that a function? No. There's got to be one, whatever input there is, it's got to be the same output every time. One output for each input. Okay? All right. So this is another way. This is another way you can show a relation. It's basically the same thing as that little table that I made over there. This is just a little different way to look at it. This is more like we call it mapping. So what it's saying is -2 maps to 5. Another way you could think of it, if this was our vending machine, you might have over here your buttons, just something like that, and then here would be the little candy bars that you'd get. Okay. So like maybe this button here for Snickers, this will give you this candy bar. This button here for a Mars bar, this will give you this one. So that's just called mapping it. You just connect the button to what you get. Okay, looking at that first one, or that first relation, what do you guys think? Will that be a function? Is that machine a function? Rosie and Lacey say yes. What's that? Does each input still have one output? Yes. So yes, it is a function. Okay. What would you guys? Could you think of what type of vending machine might have? You'll see this sometimes. What would be what kind of situation does that represent? Because the 4 gives you a 2, and the 5 also gives you a 2. Yes. Well, yeah, or there's 2 Snickers buttons, right? Or like sometimes you have a machine where there's more than one button for Coke or whatever it is, right? So each button still only has one output. It's just that multiple buttons have the same output, which is fine. Okay. What about the second one? Is that a function?
No.
No. What that's showing here is You're hitting that Snickers button. Sometimes you're getting the Snickers. Sometimes you're getting the Milky Way, whatever. Okay? So that one's not. Look at that. All right. So what are you kind of looking for when you look at a relation or when you look at a table? What don't you want to have? Okay. You don't want any input to have two different outputs. All right. Let's go on over here. You can look at it visually too. So in other words, we can write these as ordered pairs. In other words, the -2 will just plot it as a point. -2 gives you 5. Whoops. -1 gives me 0. 4 gives me 2, and 5. This is the same problem. We'll just look at it visually because there's something else I want to show you. Okay, so -2, the output is 5. Okay, -1, the output is 0. 4, the output is 2. And 5, whoops. It's got to like reset or something.
We'll get calibrated. Yeah. Yeah.
Brandon, sit down. Okay. So 4 gives us 2. 5 gives us 2. Okay. Now let's just plot this one. -4 gives us 2. -4 gives us 5. 0 gives us 3. 3 gives us 7. Okay. What do you notice about this one that just, another way you can tell if it's a function or not is when you visually just look at the inputs and outputs. What do you think tells you, Brad? Yes. In other words, how else could you describe that? Yes. If you have any 2 points on the same vertical line, we call it the vertical line test, that tells you it's not a function. Okay? So the vertical line test, you can't have 2 points on the same vertical line. Okay? So that tells you automatically it's not a function. Because when you hit this button for -4, it can give you 2 different things. We don't want that. So it's got to be a function, it's got to pass the vertical line test. Okay? So this one is a function. This one is not a function. Same numbers as the one before. I just wanted to show you it a different way. Okay. So just taking a look at a couple graphs. Let me just number these so we can refer to them a little easier. Okay. So what do you guys think? Number 1, is that a function? Yes. Number 2, no, right? It doesn't pass the vertical line test. There's 2 points in the same vertical line. Okay, so we would say no. What about this one? Yes, that's a function. For every, if you're thinking of like a musical instrument, if these were like the keys for your piano or something like that, for each key that you press, you get 1 output. No matter which key you press, there's only 1 output. Okay? What, number 4? No. Because when I press this key, how many different sounds could I get? 3. There's this output, and there's this output, right? So it doesn't pass that vertical line test. So no. Okay. What about this one over here? Yes. And that's, like I said, we'll talk about that more. That's a linear function. A linear function is whenever it's straight line. Yep. Okay, what about this one? No, not a function. What about that guy down there? That looks good. Yep, and we don't see it overlap at all. So yes. Okay, what about this one? This is a little different. Right. It's just like when we were plotting on the when we were graphing on the number line. An open circle means that that number's not included. So this is okay. There's only one output in each vertical line. So that would be yes. It's a little different. We're going to do those functions in chapter 3. Okay. I wanted to show you a couple little things here. First, oops. Let me get rid of this. Yes, Mitch.
The vertical angle doesn't require like the line to go straight across. If they're horizontal.
Say that again. You mean if you graph a horizontal line, you mean?
Yeah. That's not the same. It's vertical. It's still a function.
The horizontal one will be a function, but the vertical one won't be. Yeah. Let me, okay. This, I just wanted to show you this little thing on here because I just wanted you to get the idea of, so in other words, your input is here, and again, where do you see the output? Where do you visually see where the output is? When you go up to the graph. So here's your input right here for your x, and here's your output. So say if this is like a sound wave, making different sounds. I just wanted to just give you this little, you can just kind of, thought I could drag this along here. Let me just see here. Before I could do that. Oh, yeah, there we go. Okay. So you can just kind of see, you guys, say if you're playing an instrument, it's just kind of a neat visual. It's almost like you're riding a roller coaster or something. But I wanted you to see that's your input, your output shows up on the graph. So in a way, when you graph something, you're giving a visual of the outputs. Okay? The other one I wanted to show you guys. Now they used to have a really cool one with a nice, that had some nice sound effects, but I'll just show you this. For whatever reason, they don't have it online anymore. Yes. Yes. Okay. They used to have this same thing, and then the machine made all these funky little sounds, but this one's just silent, so it's not as fun. But anyways, we'll get the idea. What you do, I just wanted you to get the idea that think of these math functions. Think of them just like a regular machine, like a soda machine or a vending machine. I'm going to put in a number. Christian, give me a number to put in. Any number. What's your favorite number? 7. Put in 7. Gives me an output of 15. Okay? Now let's take a guess. What what are we doing to the x to get an output of 15?
Plus 8.
Plus 8? Let's try that. Yes, nice job. Okay, King Eye, give me another number. 21. 21 gives us an output of 18.
Minus 3.
Subtract 3. Correct answer. Nice job. What do you got, Brandon? 33. Output of 30. He's got to get harder here.
You gotta set new function.
Ah. Okay. Let's just do 20 here. We got 15, so minus 5. Oops.
Minus 53, nice one.
Okay. Let me go to a little bit harder one here.
I thought that was pretty hard.
This one make noises?
If that was the unit test,
No, I couldn't find one that makes the noises. Okay, this is a linear function machine. All right.
negative 12.
Okay.
Negative 1.
Oh.
Gives me a really big output. Okay, guys, this is a linear function, so we got to put in the slope and the y-intercept. Anybody have a guess? Times 6 plus 1. Okay.
3.
So we could maybe times 6 minus, no, times 10 minus 7. That's a good idea. It'd be helpful if we had a little table on the side. Oh, you're right. Maybe times 7 plus 2. No?
Try 1. Put in 1. Times 10 minus plus 3.
One gives us an output of 3. I wish it kept track of your inputs and outputs on the side, but
Show score. You know, yeah.
so 1 gave us an output of 3.
2 gave us 3. 3 gave us 1.
3 gave us 23. What about, maybe we'll put in 0.
What's negative 7? Plus negative 7.
7x minus 7. Oh, you can put in a negative. You just put in I think you can put in just a...
I'm plus 2.
Well, it's got to be a negative 7. Is it?
10x minus 7.
Plus negative 7.
Yes, good job, Rosie. Very good. Okay, I just wanted to give you the kind of another way to look at it too. Okay, let's take a look at, let's see here. Okay, a couple other things. So what we're going to do is when we have a little machine, just like that little one we were doing, that little game, we're just going to give it a name, and you can use it any letter you want. Most often we'll use F to stand for function, but you can use any letter you want. You could use F, you could use G. Later we'll talk about Say like gas mileage with your car, you could use G. Whatever, you could name the machine anything you want. When you do your function notation, this is a label for basically giving a name to your machine. So okay. And then this is the whatever variable you're using for your input. And it doesn't always have to be X. Usually we're going to just use X, but this is your input or your domain. So let's make my function. How you say this, you guys? The correct way to say it is you say f of x, or in other words, if we were to, that's a shortened form of the value of the function f at x. So we just shorten that up. We just say f of x. So let me put a function up here. Let's just say x squared minus 1, okay? So again, and this is the function that I'm going to use. If I had a couple of them, let me just say okay, let me do 3 different functions. If we do f of 3, in other words, this 3 is going to be my input. This is just another way of writing the same thing that we were doing before. If I input 3, what's my output going to be? 8. So you would say, how you say that, you'd say f of 3. In other words, when you put in 3 into that function, it gives you 8. So f of 3 is 8. That's how you'd say that. What if I did, let's do the h function. H of 2. Again, you can use basically any letter you want. That's just labeling. Tells me, okay, which machine am I going to use? And then this is the number I'm going to input. So h of 2 would be, what would the output for that machine be? At 2, 6. We're just substituting it in there. You take the 2 cubed is 8, 8 minus 2 is 6. So that's the output. I just wanted you to be familiar with that notation when you see that. Okay. If we did g of 4, that would be, so I know it looks a little confusing normally in algebra when we write 2 things next to each other with parentheses, that means multiplication, but this is a notation. It's not, doesn't mean the variable g times 4. It means it's a function notation, so don't be confused by that. What would the output for that be? We do g of 4, 13 would be the output. Okay. All right. We had talked about this just a little while ago. How would you graph this linear function? What's a quick way to graph it? Start at 4. 4 is the y-intercept, and you'd go up 2 over 3. You could also go down 2 and back 3. Good job. That's kind of rough there, but get the idea. Did I? First one, thank you. Oops, let me do that again. Did that too quick. So you start at 4, go up 2 over 3, or down 2 and back 3. Okay, there we go. Here we would start at 6, and we would go down 5, over 1, so that's a really steep negative slope. Okay. I'd start at -3, go down 1 over 4. Does it matter if I write that or that? Because this one would be, like you guys said, down 1 over 4. This would be up 1, back 4, still the same line. Can I write this? No. That would be, yep, that would be the same thing as 1/4. Usually we simplify that. If two negatives, you just make a positive. So just be careful. As long as you only have one sign, it doesn't matter where you put it. But so there's our line. Good. Y-intercept there would be 0. And we would just go up 2 over 1. Okay, good. It's a good idea to put your arrows at the end because it keeps going. Okay. How do you graph y equals 7? Yes, horizontal line. What's the output? No matter what you put in, what's the output for that function? It's always 7. If you hit this button, you're going to get 7. If you hit this button, you get 7. If you hit this button, you get 7. And that's okay. It's still a function because each input has only one output. Okay? What's the slope of that? 0 slope. Okay? This one would be, what would that look like? Vertical line. Is that one a function? No, because when you hit 3, you get all different kinds of outputs. So there's not one output for each input. What's the slope of this one? Undefined. Very good. I'm just kind of quickly reviewing a couple of the terms that you've already done. So just remember the difference there. 0 is flat. Undefined is vertical. So undefined slope. Okay. So just as a quick review, that's the last part. What are some different terms that we use for x? You could also call it the input, the domain. Y is also the output or the range. Good job. Okay. So let's take a look at your sheet. You can take out your, whoops, I want this one. Okay, here's the sheet that you started working on yesterday. And some of you guys, if you, let's see, oh, I have it over here. Some of you guys, if you need a copy. So, where's Ryan? Oh, he's in next hour. Okay, Vlad. Anybody else need a sheet? Need a set of sheets? Oh, Kevin, yes. Okay. You can just to shortcut this a little bit. It says identify the domain and the range. So which ones are the domain? Yep, these ones are the domain. So if you just want to draw some arrows, that's fine. And the range are the outputs. Okay. It doesn't ask you for that, but in these first 3, if I asked you if they were a function or not, what would you say for number 1? Yes. Yes. No, because 1's got 2 different outputs, so no. Okay, these, when it says graph the relation, what you'll just do is, if you haven't yet, on your paper, you'll just plot those points. So in other words, you'd plot the point 0, 3, and you'd plot the point 1, 5. Is that one a function? Yes. What about number 5? No, because -3 has two different outputs. What about number 6? Yes. Okay. Number 7, is that a function? Yes, it passes the vertical line test. Number 8? No, not a function. These ones here don't pass the vertical line test, so no. Number 9? Yes. Okay. Let me move this up. So I'm going to let you guys, I'll give you a little bit of time to, I'll let you finish side A. On side B, you guys, we're not going to do all of that. You can, we'll skip this part. We can even do those together. What do you think? Number 1, is that a function? Yes. Number 2? No, why not? -2 has two different outputs, so no. Okay. The only stuff otherwise that I want you to do on side B, you can actually, we'll skip these because you get enough practice on side A. So on side B, you can cross out 6 to 14. All right. And we'll do the rest of them there. Okay. What I want you to do for these, you guys, we'll talk more about this, but you're deciding if it's linear or not. For it to be linear, what does the graph have to look like? It has to be a straight line. What I just want you to do, we'll get to functions like this later in the year, but how could you tell if its outputs are in a straight line? What's something you could do? How could you tell? What's something you could do to figure out some inputs and outputs? Jewel, what do you guys think? Okay, that's a good idea. Yes. Very good. Good, Alex. Just take that and just, you might only need 2, maybe 2 or 3. Just pick a couple numbers. Even if you just want to do like -1, 0, and 1. If you plot those points, and if they end up in a straight line, that'll tell you it's linear. If not, if you end up with like a point here, and a point over here, and a point down here, then that tells you it's not linear. So that's one way you can tell. Okay. So I'll give you some time to work. And so just finish side A, graph those lines, and then finish these couple ones on side B. Okay?